The copper traces on the circuit board, the pins of the chips, and thousands of precision components come together to form a complete motherboard. The motherboard is the foundation that connects the graphics card, CPU, RAM, and other core hardware, playing a crucial role in the computer. But how does it work? What do all these tiny components do? In this episode, we'll explore the MSI Z790 motherboard, guiding you from the basics to understanding its components. To cool the electronic components and enhance aesthetics, the surface of the motherboard is covered with several layers of shielding. Once these shields are removed, you'll see all the ports and components on the board. The motherboard can be divided into 6 main areas: the I/O area in the top left corner, the CPU area at the top, the RAM area to the right, the expansion area at the bottom, the chipset area in the bottom right corner, and the various ports around the board. The I/O area is the most frequently used part. When you install the motherboard in the case, the I/O ports will be exposed at the back, including ports for network, USB-A, USB-C, video, and audio. Here you can connect peripherals like a keyboard, mouse, headset, and more. If the motherboard has Wi-Fi and Bluetooth, you'll need to install the antenna from the motherboard box to optimize signal strength for Wi-Fi and Bluetooth. The CPU is the brain of the computer, responsible for processing all data. Therefore, it is the most important component on the motherboard. In this area, you will see the CPU socket. Each type of CPU from different manufacturers will use a specific socket type. For example, our Z790 Max motherboard uses the Intel LGA1 socket, which has 1,700 connection pins and supports Intel's 12th, 13th, and 14th generation CPUs. This is the compatibility chart between CPUs and motherboards. Before choosing a motherboard, make sure that the socket and CPU are compatible. Usually, on the top left or right corner of the motherboard, you will see multi-pin power connectors. These are the power connectors for the CPU, and the number of pins on the connector corresponds to the number of power phases. Currently, most CPUs use an 8-pin power connector. Under normal conditions, this connector can provide about 350 watts, which is enough to meet the power demands of today's high-end CPUs. However, many high-end motherboards may have 2 8-pin connectors to support high-performance tasks that consume more power and cater to overclocking enthusiasts. The computer's power supply delivers power to the CPU through this connector, but the CPU typically operates at a voltage below 1.3 volts. Therefore, around the CPU area, you will notice many small square and cylindrical chips called MOSFETs, inductors, and capacitors. Combined with the PWM chip in the top left corner, they form the power delivery module for the CPU, which is responsible for converting the 12 volts power from the power supply into the voltage the CPU requires. Modern motherboards typically use multiple power phases at the same time. A MOSFET and an inductor form a single power phase, but using only one phase has many limitations. That's why today's motherboards use multiple power phases. When we talk about a motherboard's power delivery capability for the CPU, it refers to the current capacity of each phase and the total number of phases on the motherboard. For example, the Z790 Max motherboard has 27 phases, 24 of which deliver power to the CPU core. Each phase can handle 105A at 25 degrees Celsius, providing very strong power delivery. The remaining 3 phases supply power to other components integrated within the CPU and related parts. The CPU requires cache memory to temporarily store data during computations. Currently, DDR memory has evolved through 5 generations, and this motherboard supports the latest DDR5 memory. However, note that some motherboards only support the older DDR4 memory, and the slots for these 2 generations are not compatible. Therefore, it's important to verify this before purchasing. Most motherboards have a priority order for inserting RAM. For motherboards with 4 RAM slots, if you're installing only 1 stick, place it in the 2nd slot. If installing 2 sticks, use the 2nd and 4th slots. If your motherboard has only 2 RAM slots, simply install both sticks. This priority order depends on the RAM routing design on the motherboard. To learn more about this, you can refer to our previous videos. The higher the RAM frequency and the lower the latency, the faster the CPU can access data from RAM. To achieve high speed and low latency, RAM and the CPU utilize a data transmission mode called memory interleaving, which requires multiple data paths simultaneously, making it more susceptible to interference. Therefore, the RAM slots are placed as close to the CPU as possible to minimize data path length. The path between the CPU and RAM is not a straight line, but zigzags like a snake to ensure that signals reach the CPU simultaneously. If the paths are uneven, signals will arrive at the CPU late, affecting data accuracy. The design of the RAM circuitry on the motherboard affects the RAM frequency. Additionally, this is influenced by BIOS optimization, the quality of the memory controller in the CPU, and the quality of the RAM chips and other components. Therefore, most motherboard manufacturers provide reference values on their websites, which only indicate the maximum RAM frequency that the motherboard can support. The higher the value, the stronger the motherboard's RAM performance. For example, the Z790 Max motherboard has a reference value of 7,800 MHz, which is higher than the average RAM frequency of 6,000 to 6,800 MHz. However, this is not the highest limit, but the minimum achievable frequency. If you manually overclock, even higher frequencies can be reached. Below the CPU is the high-speed expansion area, where rectangular slots called M.2 slots are located, used to install SSDs, the computer's main storage, which holds software and downloaded movies. The silver slot with a metal edge is the PCIe slot, typically used for installing a graphics card. Additionally, this slot can also accommodate a PCIe SSD, sound card, 10 Gbps network card, or capture card. The PCIe slot can also be converted into an M.2 slot via an adapter card, allowing you to add more SSDs. Both PCIe slots and expansion slots use PCIe lanes to transmit data to the CPU, functioning like highways inside the computer. Newer versions and more PCIe lanes increase data transfer speeds. For example, the first M.2 slot on this motherboard has 4 PCIe 4.0 lanes, allowing data transfer speeds of up to 8 GB per second, which is 8 times faster than the previous version. These two slots connect directly to the CPU, ensuring the fastest speed and lowest latency. However, not all devices need to connect directly to the CPU, as this is unnecessary and complicates the design of the data paths around the CPU. Therefore, the motherboard has an additional chip called the Southbridge chipset, which acts like a secretary for the CPU, handling data from lower speed ports before sending it to the CPU. The Southbridge chipset helps expand ports and slots, increasing the connectivity options for the motherboard. Since the motherboard provides connections for hardware components, the chipset name is often used to identify the board. For example, this motherboard is called the Z790 Max because it uses the Z790 chipset. Each chipset has different expansion capabilities. For instance, the Z790 Max offers more ports than the B760M. However, the chipset only limits the maximum expansion capacity, and adding more ports increases production costs. So not all motherboards fully utilize the chipset's potential. Even within the B760 series, the number and type of ports vary depending on the price. Chipsets also come with special features. For instance, Intel's Z series motherboards can overclock both the CPU and RAM, while the B series only allows RAM overclocking, and the H series doesn't support overclocking. With AMD, all motherboards can overclock RAM, but only the B and X series can overclock the CPU. Chipsets are also linked to the motherboard's technical specifications. Z and X series have more robust power delivery and connectivity than the B series, while the B series is more capable than the H and A series. Along the bottom and right edges of the motherboard, there are several pins called jumpers. They are used to connect fans or expand ports. Each motherboard has different jumpers, but they usually focus on common types. At the bottom left corner is the audio pin, which connects to the audio cable from the case, helping to extend two 3.5mm ports for headphones and a microphone on the front of the case. The pin on the right is the RGB jumper used to control the LED lights. When connecting LED lights and fans, you can create stunning RGB effects. The 12-volt 4-pin RGB jumper is the older type, where devices connected to this jumper can only change colors uniformly, meaning all LEDs change to the same color. Meanwhile, the 5-volt 3-pin RGB jumper allows for individual LED control, creating dynamic and unique lighting effects. Next are the jumpers for the fans and water pump, allowing the motherboard to supply power and control the speed through these jumpers. The USB jumper port functions similarly to the audio port, connecting to the case to expand the front USB ports. This motherboard has 2 USB 2.0 jumpers, 2 USB 3.0 jumpers, and 2 USB 3.2 jumpers. These 2 buttons are used for quick boot and system reset. The front panel FP jumper connects to the power button, reset button, power indicator, and hard drive indicator. The SATA ports are used to connect HDDs and 2.5-inch SSDs. The 6-pin port powers the front USB-C port, supporting high-power fast charging. The 24-pin port provides power to the entire motherboard. The 2 numeric LEDs in the top right corner display error codes when the system fails to boot. The 4 small LEDs below light up when hardware issues occur, helping you troubleshoot and fix errors easily. High-end motherboards have many special pins and components. For example, these 2 jumpers connect to temperature sensors in the case. When overclocking with liquid nitrogen, extremely low temperatures may prevent the motherboard from booting, and the 2 jumpers in the bottom right corner help force it to start. There are also other jumpers and buttons that are rarely used. If needed, refer to the motherboard manual for detailed information. Besides connectors, slots, and capacitors, the motherboard also has various auxiliary chips, the most common being the integrated audio chip, also known as an onboard sound card. Additionally, there are chips for USB port expansion, power management, clock synchronization, and data transmission control. All these components work together to ensure smooth computer operation. Apart from the hardware, motherboards come in different sizes. Currently, the most common sizes are large ATX and medium-sized MATX. Additionally, there are extremely large eATX and compact ITX. The size of the motherboard affects compatibility with the case and determines the board's expandability. However, smaller motherboards are not necessarily inferior in terms of expandability. Many high-end ITX boards even offer better connectivity than lower-end MATX boards, depending on the manufacturer's design and positioning. It all depends on how the manufacturer designs each model. Now that you understand the structure of the motherboard, for all the hardware to function, a set of guiding rules is required. For example, what specifications should the CPU and RAM operate at? How should the components communicate with each other? These basic rules are called the motherboard's firmware, also known as BIOS. BIOS is stored in the motherboard's BIOS chip. Some high-end motherboards are equipped with dual BIOS chips to prevent overclocking from causing BIOS errors that prevent the system from booting, allowing you to switch between the main and backup BIOS chips. BIOS provides a setup interface, allowing users to adjust certain options. When you see the motherboard logo during startup, you can press the delete key to enter the BIOS interface. High-end motherboards like MSI often have a graphical BIOS interface, making it easy to view hardware information, operating status, and specifications. You can also overclock the CPU and RAM with just one button or tweak deeper settings. To prevent incorrect settings from stopping the system from booting, BIOS can be reset using a physical switch. On low-end motherboards, you need to power off and remove the button battery from the motherboard to reset the BIOS, which is quite inconvenient. Some mid-range motherboards allow BIOS reset by shorting a jumper on the motherboard. High-end motherboards like the ZZ790 Max have a reset button on the rear I/O panel, so you can reset the BIOS without opening the case, which is very convenient. The motherboard's BIOS is updated periodically, not only to fix bugs that cause hardware instability, but also to add new features, such as support for next-generation CPUs or performance optimizations. However, if your system is running stably, we do not recommend updating the BIOS frequently. Now that you have a comprehensive understanding of the motherboard, let's discuss how to choose the right one. Generally, there are 5 factors to consider: the CPU socket, motherboard size, power supply, supported RAM frequency, and expandability. The CPU socket determines whether your CPU can be installed. The size of the motherboard will dictate its compatibility with the case, not too large or too small. You can flexibly choose based on the size of your case. The power supply affects whether the motherboard can maximize the CPU's performance, and you can refer to user reviews and tests to learn more. Supported RAM frequency will impact whether you can use high-quality RAM, and this information can be checked on the manufacturer's website. Expandability determines whether the number and types of ports meet your needs. You can refer to the motherboard's specifications to assess this based on the number of devices you have. Additionally, you should also consider whether you like the motherboard's design, whether the port layout is convenient, if the BIOS features are robust, and whether the bundled software is useful. By considering these factors, you will easily be able to choose the right motherboard. Of course, if you are unsure about your needs, you can also refer to reviews from other users. This episode provides a basic overview of motherboards. While it is difficult to fully explain how to choose a motherboard in just one video, this information should give you a good grasp of the basic structure and main components of a motherboard, helping you go from knowing nothing to being an informed beginner. You will feel more confident when selecting a motherboard. If you found this program helpful, please remember to follow and support us. Your support is very important to us. Thank you for watching the entire video, and we look forward to seeing you in the next episode.